Malcolm Training Tutorials, NetBox, Asset Interaction Analysis. In this video, we will explore asset interaction analysis, which enriches network log data with context from the asset inventory maintained by NetBox, a powerful tool included in Malcolm for network modeling. We'll demonstrate how to pivot from NetBox to network traffic data using the dashboards for a more informed view of our network traffic. More information on NetBox and the Asset Interaction Analysis dashboards can be found on the Malcolm GitHub site, for which links can be found in this video's description. For a high-level review introducing NetBox and its role in Malcolm, please watch the NetBox overview video on this channel. What is Asset Interaction Analysis? Asset interaction analysis is viewing network traffic log data in dashboards through the lens of an inventory of network devices created and maintained in NetBox. This network asset inventory is a model of the devices that make up your network, as well as their IP addresses, information about hardware manufacturers and models, the roles these devices perform, and more. However, this information is static. It tells us what devices are on our network, but not what those devices are doing. On the other hand, we have network traffic logs displayed in OpenSearch dashboards and Arkime. This network traffic metadata, generated by Zeek and Suricata, gives us a real-time view of what is happening in our network. It shows us the communications among devices on the network, as well as traffic between those devices and the internet. As Malcolm processes network traffic logs, it queries NetBox to look up information about the devices observed in that traffic. Those logs are enriched with the details provided by the NetBox inventory. We call this enrichment, and the dashboards used to view the resulting data asset interaction analysis. It acts as a bridge between the live network traffic logs generated by Zeek and Suricata and NetBox's static network inventory.
Devices represented in NetBox are defined by their manufacturer like Dell, Rockwell Automation, Schneider Electric, etc., and device type like a model number or SKU. Each device can also be assigned a role, the function the device fulfills in the network. HMI, historian, file server, and workstation are just a few examples of the roles that can be assigned to devices. Devices' IP addresses are used as traffic is processed to identify which traffic belongs to which device. Pivoting between NetBox and dashboards. There are two methods for populating the NetBox inventory: manual population and automatic population. A discussion of the pros and cons of these methods is beyond the scope of this video. Regardless of how the inventory was populated, one of the benefits of asset interaction analysis is that it can reveal devices communicating over the network that are not accounted for in the inventory. We want to be aware of devices communicating over our network that aren't listed in our inventory because it could indicate either of two things. It might be a legitimate device that belongs in the network, but that we forgot to inventory, or it could be something malicious, a rogue device. In the first case, suppose an IT worker is performing tests on a new model of employee workstation and connects it to the network with a new IP address. Because this device does not show up in the network inventory, information about it could not be looked up when processing the logs generated by its network traffic. On the other hand, imagine a disgruntled former employee who installed a small Raspberry Pi single-board computer out of sight in the server room before leaving the company as a backdoor for him to maintain access to corporate resources. In both scenarios, these devices would show up as uninventoried. It's up to the user to interpret what each uninventoried device represents. The Asset Interaction Analysis dashboard focuses on the devices observed in network traffic from the perspective of the connections between them. As the logs populating this dashboard include source and destination components, we can visualize traffic between different segments of our network. In NetBox, under IPAM IP prefixes, we have defined the subnets that represent various segments of our network, such as the office network, battery network, and more. With asset interaction analysis, we can see the flow between different network segments using the cross-segment traffic visualization. This diagram represents the connections, showing the percentage of traffic flowing between network segments. It helps us understand who is communicating with whom in our network, provides insight when working to minimize unnecessary cross-network communication, and gives evidence to use when validating our network design.
We can also see a breakdown of network segments by protocol. For example, by filtering on the battery network, we can see which protocols are being used by devices in that network, such as SMB, RTRDP, NTLM, Modbus, and more. This helps us understand the activities within each network segment. Additionally, the dashboard ties into Malcolm's event severity scoring, allowing us to see high-severity events such as rejected connection attempts or file transfers of high concern, based on the network segment they occur in. It also shows alert signatures and other red flags in network traffic grouped by the network segments they exist in.
You can view a summary of all the protocols being used in your network traffic. For instance, if you want to know which devices are using Ethernet IP, simply click on that protocol to add a filter, narrowing the displayed logs down to only those associated with devices communicating over that protocol. With the filter applied, you might see the device using Ethernet IP is your Turbine PLC device in the combined cycle BOP network, and that is a Rockwell automation device, model Logix 5555. Once a device of interest has been identified, looking up that device in NetBox can yield more information about the Turbine PLC that may have been entered when it was inventoried, such as its serial number, interfaces, configurations, or even images associated with this. Now let's look at the observed software categories included in the Zeek Known Summary dashboard. These categories show the types of software used for communication between devices. For example, to find out which devices are acting as HTTP servers, click on the HTTP server category to apply a filter. This will narrow down the list to only the devices serving as HTTP servers. You'll see that the cellular modem, Modbus Client 12, battery HMI, and Modbus Client 55 on your battery network are all exposing an HTTP server. Additionally, there's a device on the wind turbine network serving an HTTP server, but it doesn't have a name associated with it. This raises the question of why this device is unnamed. To investigate, copy the IP address of the unnamed device and search for it in your devices list. If the IP address isn't found, it indicates that this device has not yet been inventoried. Now that we know the device with this IP address is not represented in our network inventory, we can use that IP as a starting point for investigation. Searching for that address in the Overview dashboard will reveal what types of logs are associated with it, which can in turn point us towards more specific dashboards for examination.
Malcolm normalizes all of the IP addresses associated with a network traffic log into a field called related.ip. Filtering the related.ip field with an IP address will return all logs associated with that IP address, whether the device was acting as a source or as a destination. From the Overview dashboard, we saw that this device communicated using the HTTP protocol, so we might pivot to the HTTP dashboard where we can see that there were 9 HTTP logs associated with this IP address generated at around 3 o'clock, showing the source and destination of the connections. It looks like this device hosts an HTTP server on port 8080 and another device with an IP address ending in .129 connected to it. Further investigation would reveal additional details such as the user agent and the different paths retrieved on this server with the IP address for which we're filtering. Going back to the overview, we see another type of Zeek log for this IP address is files. This would prompt us to pivot to the Files dashboard to see what files were served by this web server we're investigating. It looks like 8 HTML files and 2 plain text files were served, and we could do additional investigation based on those files. After our investigation, we could come to one of 2 conclusions. Either this is a rogue device that shouldn't exist in my network at all, or it is something that should exist in my network and I just need to inventory it. At that point, we could create a new device entry in NetBox, providing details such as site, name, device manufacturer, and model, role, and IP address. Whatever information we know about the device, whether it was learned from our investigation of the network traffic or through other means, should be included as we add the device to the NetBox inventory. We can repeat this pattern, filtering on the IP addresses or other aspects of uninventoried devices, then pivoting to other dashboards to learn more about them, as many times as necessary to discover information missing from the network inventory and use it to fill in the gaps in NetBox. Up until this point, we've primarily approached asset interaction analysis from the dashboard side, then pivoting to NetBox based on what we saw there. However, we can also go in the opposite direction, using the NetBox user interface as a jumping-off point to pivot into dashboards. For example, if I'm interested in a cellular modem in my network, when I click on that device in NetBox, I see two special links: Asset Interaction Analysis and Arkime. These links are for convenience, saving us the trouble of manually searching and creating filters in dashboards in Arkime. Let's begin with the Asset Interaction Analysis link. By clicking on this link from any device, IP address prefix, or site, we can directly access the traffic associated with that specific entity. Selecting Asset Interaction Analysis opens a new dashboard tab with a device filter that corresponds to the chosen device. When pivoting from NetBox, Dashboard's search time frame will be set to its default, so we might need to adjust the time frame to cover the time period of interest. Additionally, there is an Arkime filter available for devices in NetBox that functions similarly to the one for dashboards. Clicking on the Arkime link opens an Arkime session with the device filter already populated. When expanding a Zeek log or Suricata alert for any traffic data enriched by NetBox, we can view NetBox sections containing details added during that enrichment. For example, the source device of this connection has an IP address which corresponds to that of the cellular modem in our NetBox inventory. This additional context added during the NetBox enrichment provides further context for the network traffic. Similar to the capabilities in dashboards we discussed earlier, Arkime also offers built-in views, or filters, for uninventoried assets and services. Asset Interaction Analysis integrates observed network traffic with details from your curated asset inventory, providing deeper insights into network interactions and allowing us to effectively analyze and validate our network design. This concludes NetBox, Asset Interaction Analysis. Check out the description section for links to the Malcolm GitHub site, a Malcolm discussion forum, and more.